Good morning, or evening, or maybe even night to you. I am here with a video talking about triangles, which is our newest unit. The first part of this is going to be somewhat review. In this video, at least all of this should be review. It is something you learn in middle/maybe elementary school, but since we're going to get more complicated stuff, I want to do a quick review of the easy stuff so that I don't have to talk about it as much when we get to the harder stuff. So today is just classifying and some vocabulary. So classifying triangles, there are two ways to classify. First one is by angles. In a triangle, you have three angles. You know, tri, is a prefix. In anything, because, you know, it's Greek, tri means three. So you can classify it by its three angles, or you can classify it by its three sides. So three acute angles, like these ones are pretty self-explanatory types of triangles. Sorry, I'm swallowing a peanut M&M. Anyways, three acute angles is just going to be called an acute triangle. So if anyone ever says they're talking about an acute triangle, that just means all of the angles here are acute. That is less than 90 degrees. So less than 90 degrees. That is the less than symbol, by the way. One obtuse angles means we're going to call it an obtuse triangle. Note that it's impossible to have more than one obtuse angle. You simply cannot in a triangle have more than one. Like if you were to make an obtuse angle right here at the top, and then you were to draw another obtuse angle right here, with these two obtuse angles, with an obtuse angle up here and another obtuse angle over there, you can see that, you know, this isn't a triangle. If this keeps going forever and that keeps going forever, they're never going to meet up to make another triangle. So if you have one obtuse angle, the only way to make this into a triangle is to connect the dots, and that automatically makes them acute angles. We learn a little bit more about why in the next lesson, but there's only ever going to be one obtuse angle. You cannot have any more. One right angle is just called a right triangle. I'm just going to draw a triangle because I'm lazy. And then three congruent angles is called equiangular. Or once again, they use one of those prefixes, equi. Equi means equal or the same. So it literally is translating to same angle. All three of them are same angles. The other ones don't have to be the same angle. Maybe this is a measure and this is a different measure. In math, with the symbols, I'll zoom in. Whenever you see these little arcs like that, if they are the same arc, then they are considered to be like equal angles or congruent angles. So like if I drew this would say those two angles are the same. If I drew this, that would mean all three angles are the same. Whereas if I was to draw two arcs, that would mean that they're definitely different. So these two would be the same, but this one is different than those two. And if I was to draw three arcs on one of them, then this is saying 100% these are three different angles. So this is an angle, this is a different angle, and that's a completely different angle. So when you see those arcs, that's what it means. But for these ones, when we're doing it by angles, it's the type of angle, acute, obtuse, or right. We don't care if they're the same or not at the moment, except for this one where it says they're equiangular. By sides, three congruent sides, instead of equiangular, is equilateral. Equilateral triangle. Two congruents. I don't know. Do you guys remember? Maybe you want to take a second to think about it. Do you remember what it's called if you have a triangle with two sides that are the same? It starts with an I. And it's isosceles, which I think I spelled correctly. So an isosceles triangle. And then most people don't remember no congruent sides. So like if this is length 1, this is a completely different length, and this is another completely different length. Much like the arcs, a different amount of little tiny lines says that they are different. So these two are the same, but this one is not labeled because maybe it's the same, maybe it's not. Because technically an isosceles triangle, an equilateral triangle is a type of isosceles. Because if you just kind of covered this up, two sides are congruent. So since two sides are congruent, it's isosceles. So isosceles can have all three sides the same, or it could have where it is different. It doesn't matter. So that's why it's not labeled. But this one, all three are different. So this is a length, this is a different length, this is a third length, and that is called a scalene. And just say the word scalene out loud, because it's really fun to say scalene. Scalene. Yeah, scalene. Naming angles and sides. This is even a review of this review. Naming an angle, when you name an angle, the first way to do it is just to call this angle 1. You can do that because it has something there. Sometimes in math in later years, you'll see like a Greek letter there. That's usually not until like pre-calculus when you get that high. But if you have something like an alpha or a beta there, sometimes they'll just say angle alpha, or so they would just write alpha. But you know, that's not what we're doing in geometry. I just wanted to mention it for your future. You might see that. In which case you don't even need the angle symbol. But if it's a number, we're going to put angle 1. If you're using the letters, which we're going to have to in some cases, you do have to make sure that once you start writing your angle, after the angle symbol, the vertex does have to be in the middle. So A, B in the middle, and then C. The other possibility is to do the C, the B, and the A. The C, the B, and the A. But it's very important that the B has to be in the middle. It's always assumed that the vertex is in the middle. Whereas if you were doing a triangle, instead of doing the angle symbol, you do the triangle symbol. Math is very, very unoriginal. You know what the symbol for triangle is? It's a triangle. Ooh. Ah. So instead of saying like an angle XYZ, you would just do triangle XYZ. And since we're talking about the triangle, it doesn't matter the letters. You could do X is ZY or Y X Z, whatever. It's just the 3 points that are connected to make a triangle. And it's literally a triangle in front. Okay, next comes two vocabulary words: an included angle or side and the opposite angle or side. And I like to look at this as a picture first and then talk about its definitions. So I'm going to go turn this over to a blank sheet and talk about triangles. And I'll start with the opposite angle from a side. Okay, so the opposite angle from a side. So I'm just going to go ahead, maybe I'm talking about this side, maybe I'm talking about that side, maybe I'm talking about this side. Those are the three possibilities. I drew the same triangle, so we're either talking about this side, that side, or this side, and that's the three things I just did. So opposite just means, going kind of across, and if you were to do that in this first one, if you were to go from this side and go across and keep going across, you'll see that you eventually end up at this angle right here. So this angle is going to be the angle across from it. Whereas in this one right here, if you were to go to across from this side, you would end up at this angle right there. And you end up with things like this. Let's just call this ABC. Then you would say opposite of line segment AC, opposite of line segment AC is going to be angle B. So that's how you would write that. Opposite AC is angle B. And here, if I relabel them again, if you go opposite of AB, you would see you're at angle C. So angle C is opposite AB. So then similar here, if you want to like pause it and see if you can do the same thing I did, you're welcome to. But we're starting with BC. And opposite BC is going to be angle A. So that's it. That's how you do the opposite. And you know, it could be asked either way. I could say the opposite angle from a side, or I could say what's the opposite side from the angle. Those are the two things that could be done. But either way, it's the opposite something from a something. But opposite of a side is an angle, and the opposite of an angle is a side, always, like that. Because sides are going to be next to it, right? This side is next to that, and this side is next to that. So you wouldn't call it opposite. If you go opposite it, you're going to find an angle from a line segment, or vice versa. So there you go. I'll just organize this because I like organizing. And that's it. That's how it is. So we can go back to the actual definition stuff now. Included, oh, I just did opposite. I didn't do included. Here we go. So let's go down here to included. And it's going to be very similar. The included angle from two sides. Or you can have an included side from two angles. And it's running out of ink. Okay. So once again, some sample triangles. Let's go with XYZ this time. And we will see what happens. So we're saying we have two sides in this part, right? Included angle from two sides. So maybe I have these two sides, maybe I have these two sides, and maybe I have these two sides. And I recommend just taking a second and looking at it to realize that those are the only three options, that it's not possible to choose any other two sides besides that, no matter what. So you can see when I'm doing these three cases, it's literally the only three things that can happen. So the included, like if you just look at this now, you might be able to anticipate what's going on. The included angle from the two sides. So like if you have these two sides, the included is just going to be this part right here in between them. In this one, it's this part here in between them and this part here in between them. So if you have angle X, that is the included angle from XY and XZ. So XY and XZ. And same thing, it can be asked either way, like given these two line segments, what's the included angle? Or if the y is the included angle, then what are the two sides? Now, that's less common, but it does happen. If you have angle y, what are its two adjacent sides? It would say that. Or what is it? What is the included angle of? And you'd say those two sides. But it is, if you have two sides, the thing included is going to be an angle. Included is definitely a very important vocab word to know. So here you would have YZ and XZ are included with angle Z. Something like that, whatever. So with XZ and YZ, Z is the included angle. And from two angles. So once again, I'll show you the three possibilities, and I recommend just kind of justifying within yourself why there's only three possibilities. Like, it's impossible to choose any other two angles. And this time when you look at it, you can probably see that between these two angles, there is one side that connects them. So given two angles, the included side is there. So given Y and X, you can see that YX is the line segment that connects them. Right? If you're given angle Y and angle X, YX connects them. Which, you know, when you do these problems, you can sometimes just know that without even looking at the picture. Like angle Z and angle X would be XZ. Like if I was just to cover this up all of a sudden and put just angle Y and angle Z, angle Y and angle Z, the thing that connect them is YZ. And it's just because, you know, that's the angle at Y, that's the angle at Z, so the thing that connects them is going to have to use the point at Y and the point at Z. A similar thing happened here, actually. I don't know if you would have noticed it, but XY and XZ, what do they share? And that is the letter X, which not so coincidentally was the first part of that. And you know, with since I didn't do that middle one, you could do something different. The included angle from two sides. So if I did XY and YZ as my two sides, you could look and say, well, look, they share the letter Y, so angle Y is going to have to be the answer. There are some exceptions to that, because one thing we learned about angles is that if you have more than one angle at a letter, you can't just use that letter. So like if there was a letter line segment here, you couldn't say angle Y, you would have to say angle XYZ, like we did on the front. Using three letters to show that it's XYZ rather than like AYX or AYZ. So you couldn't do that. But anyway, this is mostly just kind of getting a feel. So included, you know, if you feel like you know what included is, you don't really have to write anything, especially if, you know, you're not using the sheet anyway. But included angle is the angle or side between the two angles or sides given. And that is the opposite, I don't know what to call it, the opposite angle side from the side or angle given. So notice that I did have to change the order, because if you start with an angle, the next one will be a side. And if the first one is a side, then the opposite will be an angle. Okay, that's it for that. So here's the actual example. I would once again recommend that you pause it right now and try it. So pause and unpause, which if you paused it, you wouldn't be able to hear me say unpause, but I'm gonna ignore that. The side opposite angle X, so if here's X, we go across, it looks like the answer will be YZ, line segment YZ. And then the angle included by X, Y, and YZ, well, if I wanted to, I could just see that they share Y, so my answer has to be Y. Or I could say XY is here, YZ is here, so the angle between them is angle Y. Done. Okay, hopefully it was helpful. See you guys later.